So this 12.3, we look at vectors with the geometric problems. So there are no notes for this part because we can't. There's no notes where you can do one rule fits all problems in here. We just have to play it by ear every question. Example number 1. A, B, C, D are the points. These are the points. Find AB and DC. Give your answer in the form of PI plus QJ plus RK. So, well, you've learned a shortcut and find AB. So to find a vector AB, that will be the same as doing B minus A. Okay, so it's the second letter. Take away the first. So B is 1 minus 7 minus 3. Take away A. 2 minus 5 minus 8. So like B away A. So AB, B minus A. So that equals to minus 1, minus 2, and 5. And therefore, that will be the same as minus I minus 2J plus 5K. That will be AB. They ask us to put in IJ and K form, therefore we have to. DC. So DC is C minus D. So C is 0, 15, minus 10. Take away D, CD. So it's the second letter, take away the first letter. 2, 19, minus 20. So which that gives you minus 2, minus 4, 10. So minus 2 and I, minus 4J, plus 10. But one thing I'd like to ask you about vector is to show that they're parallel. To show they're parallel, hopefully you know you're not a stranger to this. You would factorize anything to see if the vectors are equal. Well, part B, we can see DC. For DC, we can factorize a 2 out. So that will be 2 bracket minus I minus 2J plus 5K, which is same as 2AB. So therefore, they are parallel. Okay. So you just have to show the vectors are the same. The IJ and K, they are the same. They are a multiple of another. Nice and easy. Right. Next. Example number 2. PQR are the points, respectively. Find the coordinates of the point S so that PQRS forms a parallelogram. So we can draw a parallelogram. Actually, I can make use of the board. Where's my parallelogram shape? Is there one? Yeah, that's one. Yep. So we can say PQRS. Now, why do they like to use parallelogram in vectors? Because they're parallel. In vectors, parallel means they have the same vector. So what we know is, we don't know S, so we're going to let S be X, Y, and Z. Now, how can we use the properties of parallelogram to set some equation to help us find S? You can make them equal each other. Yep. So opposite lengths are equal and parallel. So therefore, we can say PQ will be equal to SR. Or we can say PS will be the same as QR. So you just have to use either one of them. So you have to use either one of them. let's say we choose the first one. It doesn't matter what we use, to be honest. So PQ equals SR. So PQ is Q minus P. So Q minus P, Q is 7 minus 7 minus 7. 7 minus 7 minus 7 minus P, 4 minus 9 minus 3 equal SR. So R take away S. 8 minus 2 minus 0 is 0. Minus S. The PQ equals SR. Okay. Right. Silly mistake student will make is sometimes they forgot to write the minus somehow when they copy it. You know, they somehow just put a minus, extra minus in there, but the minus 7, they forgot the minus in the second 7, etc. So just be mindful how you copy it. And then you just simplify left and right hand side and then make them equal. So left hand side, you get 3. Oh, I did differently. Minus 7, 2, minus 7, minus 4, equal 8 minus x, minus 2 minus y, and negative z. Guess what next? We'll make each line equal. Okay, so we can find x and y and z quite easily. Make each line equal each other. So for the top 3 equal 8 minus x, x will equals to 5. Second line, y equals to minus 4. And the last line, z equals 4. Therefore, s equals 5 minus 4, 4. Okay, done. So I know it's important, but we have to use the fact about parallelogram. So right, next one. Example number 3, given that 3i plus p plus 2j plus 120k equals that one, find the values of p, q, and r. Maybe I'll give you a minute. You can pause the video, have a go at the question. If you have no clue, you can carry on. You can play on the video and listen to my explanation. I would suggest you have a go. So first, you can write them in column vector. That's easier. So 3p plus 2 to 20 equal p negative q and 4pqr. Anything apart from k has to be written in the k position, 4pqr. So this becomes, you just open line by line, and you work out a value of p, q, and r. Right. So from the first line, we can clearly tell p equals 3. Now from a second line, because when p is 3, q will be minus 5. And therefore, last line, 120 equals 4pqr. Now, the P and Q value depends on the previous one, so just be mindful. If you got it wrong in the previous P and Q value, you got the R value wrong. So 120 equals 4 times 3 times minus 5, R. 12 minus 60, R equals minus 2. Okay. Next, where the real challenge begins. Or began. Because this was in year 12. Now, one thing to note, this was not on the notes. If you watch the video, this is not on the notes because this was given extra on top of it. So if you got the notes, you will see underneath it, there's no page number because this was not part of it. I want to do this. This is based on year 12 mechanics, and not mechanics, vectors. So year 12 pure maths vectors to prep you up about 2 diagonals by setting each other before we do the 3D. Right. So now, if you're confident enough, or if you want to try it, I would suggest you try it because this is year 12, essentially, pure maths. So if you're watching the video, you can press pause the video and have a go with a question. So just have to draw the shape. O, A, B, C is a rhombus. That's a rhombus. In a rhombus, their opposite lengths are parallel. It doesn't look quite right, but you get an idea. So O, if we have O, A, B, C. Right? So OA is A and OB is B. So I'll need you to do part A and part B first, and then I will go through part C with you about proving diagonals bisecting each other. So here are the answers for part A and part B, not going through in detail, so you can check your answer. We need these two for part C. Prove the two diagonals of the rhombus bisect each other. So if I draw another diagonal, that means from A to C, okay? Part C. So we're gonna let I'm gonna let M be the intersecting point. Okay, so we're gonna let M to be the intersecting point. So let's call that point M. Now, when they say that bisecting each other, what does that mean mathematically? Or in terms of definition, what does bisect mean? Perpendicular bisector, anything you've learned GCSE, year 1, what does bisect mean?
It means at 90 degrees.
No, that's perpendicular.
Oh.
Bisect means they cut into half, cut each other into half. Okay, like siblings, you bisect. No, actually, that's not that. Bisecting means you cut each other in half. So it means OM, okay, and MB will be equal in length. And if they do bisect each other, that means CM will be same as MA. Okay, so on a side note, okay, bisect. If diagonals bisect each other, then now write in green because this is what the idea behind it, behind the maths. Then AM will equal MC and OM will equals MB. Now, but we don't know anything about M. So another definition is, another definition is, if they do bisect each other, yes, that means they cut into half. It means AM will be half of AC. Now, the reason we have to use another definition is because we don't know anything about this mysterious point M. So we can also rewrite as AM is a half of AC. And OM will be a half of OB. Okay, if they do bisect each other. Okay. So this is the key definition we're going to use. The question is it a half though? We don't know, we have to prove it. Okay, so we have to prove it's a half. If they do bisect each other, it's a half. So this is where the real steps begin. Okay, we'll let M to be an intersection point. Okay, then we're going to let AM, so we're going to let AM equal to lambda of AC. Now you should have done something similar last year. Not sure if you remember. And we're going to let OM equal mu of OB. After the calculation, what would you expect to be the answers for lambda and mu? A half. Okay, so that's the aim of the proof. Okay, so you expect lambda and mu to be a half. So, right. So in here, we let AM equals lambda AC. So I'm going to make this equation 1 and equation 2. Okay, so from equation 1, so AM equal lambda AC. We do know what AC is because AC, we've done this in part B. AC is B minus 2A. Just going to slightly expand it. Lambda B minus 2 lambda A. We'll do the same with equation 2. From 2, OM equals mu of OB. I think, what's OB? OB should be. So right here, we've got AM, an equation of AM, an equation of OM. Now it's time for some collaboration. We need to try and merge them together because so far we've got 2 equations, but we're not doing any calculation between them. So how can we do a calculation between them then? How can we merge them together? Well, this is the third step. We are going to rewrite AM with OM. So step 3, I'm writing green just for you to explain my logic behind. So to merge AM and OM together, OM equations together, we're going to rewrite AM in terms of OM. So what does that mean? Well, if I want to develop a route from A to M, including OM, how would I write the route? Route means journey. How will I go from a journey from A to M with the help of OM? So we look at diagram again. How can I go from A to M? That includes OM. Well, A to O, A to O, O to M. So if I do want to go from A to M with OM, this has to be the only route. Okay, so A to M plus O to M. So AM equals AO plus OM. Well, then here we've got an equation that merge AM and OM together. So we know what AM is. AM is lambda B minus lambda A. I'm going to color code it for you. So that's your yellow. That's your blue. So AM is lambda B minus 2 lambda A. AO is AO. AO is minus A. But OM is mu B. So just to show you where each part go into. And then last, we can then compare the A and B. So we can compare the coefficients of A and B. It's like I and J, but we compare A and B instead. So if we compare A, you can see the left-hand side is minus 2 lambda. On the right-hand side is minus 1. Are we in sync? Are we following? No response? Right, equals a half. So if we divide 2 minus 2 over, it's a half. If we compare the coefficients of B, on the left-hand side, we've got lambda. On the right-hand side, we've got mu. So lambda equals mu. We know lambda is a half, so mu also equals a half. So proven. Well done. Because we said the whole point of this proof is to show lambda mu equals a half. So I'll do a quick recap of what you've done, okay, and then you can try to apply it again in next question you wish. So to prove that they are bisecting each other, or sometimes could be a different ratio, for example, 1 to 2, 2 to 3, it all works the same. First of all, you have to let them intersection point, and then you will have to set the equation where AM, half of it, is lambda of the whole length. Do this same with the other, and then rewrite the equation AC as the use AC to use the information, work out AC and OB. So you've got two equations with B and A, and then to merge them together to do some collaboration between them, you need to rewrite AM with the help of the other, and that's when you write them in one line, put these two equations in one, and compare coefficients of A and B. Right now, if you haven't got the notes for the next question, I suggest you can use this to help you to try the question. You can also go back to the video and look at the working out again to help you with this question. But I'll suggest you pause the video and have a good go at the question. So before moving on to part C, here's the answer for part A and part B. I'm probably not going through a lot of details in this one. I think you should be able to figure it out. I did write down the one by one quite clearly, so you should be okay. So again, pause the video for part C. Follow the instruction or the workout from the previous question. You've got the intersection point. So your first task is to let the equation, step the equation. Right, carry on. So here we're going to first start letting, because there's an intersection point already given to D, so we don't have to let D to be intersection point. We just start with let SD to be lambda of ST, and MD equals mu of MN. We've got equation 1, equation 2, or actually, yeah. So we can actually write SD equals lambda of ST. ST is the same as 3/5 of A minus B. So that will give you 3/5 of lambda A minus lambda B. On the second equation, MD will equals to mu of MN. MN is A plus 3/5 of B, which if you expand the bracket, that's mu A plus 3/5 of mu B. The next step, we're going to merge them together, so we can rewrite SD. So SD will equal, you can also do MD equal. So if you start with SD equal, you get SB plus BM plus MD. Now, second version, if you do MD, you can do that as well. So MD would equals to MB plus BS plus SD. Every year, a student giggling at BS, the word. No one this year, quite mature, well done. SD equal SD plus BM plus MD. So if I go with my first one, then you should get 3/5 of lambda A minus lambda B equals minus the 5th A minus 4/5 of B plus mu A plus 3/5 of mu B. Next step, compare the coefficients. So if I compare coefficients of A, I'll get 3/5 of lambda equals a 5th plus mu. If I compare coefficients of B, I will get minus lambda equals minus 4/5 plus 3/5 mu. Then this becomes really simultaneous equation. You make one variable subject and substitute into the other. So I'm not going to show you the step in between. This is basically how I have to do it. So mu, if I make this mu the subject, so 3/5 of lambda minus a 5th equals mu. I can sub into that. And then minus lambda equals minus 4/5 plus 3/5 of 3/5 lambda minus a 5th you will get expand everything, bring lambda to one side, you get minus lambda minus 9 over 25 lambda equals minus 17 over 25. Just be mindful in the calculator when you put the simplify the lambdas, it's -1, take away -20 over 25. So we get negative 34 over 25 lambda equals minus 17 over 25. So divide 17 by 34, you get lambda equals a half, and subsequently you find mu equals a half as well. Proven. Okay. Right. So that's the bisection question. Hopefully you should be a bit more confident than last year when you see a similar question. Okay. Right. Next. Last but not least, 3D version of it. Same steps, everything the same, but it's a 3D version. Okay. Let's have a go at a question. The diagram. So it's a cuboid whose vertices are OA, B, C, D, E, F, G. It's clearly I have not learned my alphabet song. OA, B, C, D, E, F, G. Vectors A, B, C are the position vectors of the vectors A, B, and C, respectively. Prove that the diagonals OE and BG bisect each other. So OE was OE, O is there, and BG is there. Okay. Right, so this reminds me of a game show. It's got, I think, the Cube. Is it? I miss it a lot. Is it still playing right now? I don't think so. It stopped, right? I don't know. I love to watch them a lot. Right. So anyway, to prove that bisect each other, you start by saying let M be the intersection point. Intersection point. So that M is right in the middle. Okay. Then we can start our letting our two equations again. Okay, can anyone tell me what are the equations that I should be letting? The first two. We let BM equal lambda of BG. And OM will equal to mu of OE. Obviously, if our answer is correct, we should get lambda and mu equals to a half. Now, on a side note, what if the question, okay, I'm just changing the question here just to show you the difference of the working out. If I want to show OE to BG, let's say they're not bisecting each other, is 1, 2, 3. Let's say, okay, let's say. How would that change? So I want to show OE cuts BG into 1, 2, 3. Then your lambda, you would do everything the same in letting these two equations, but your answer, because BG is 3 times of OE, actually. Actually, it was not a question. It's not something question. Sorry. Can't think of a question. I can't write it properly. But if the question was 1, 2, 3, the essentially lambda value will probably be a quarter, and this will the mu value will be a 3/4. So everything I'm trying to say is everything will be sort of similar. Okay. I don't have the exact question with me. But if they're not bisecting each other, the lambda mu value will change basically accordingly. But you will get things working out. So next step from 1 and 2. Okay. So this time we don't have part A and part B to help us to find BG and OE, so we have to do that first. So from 1, okay, from equation 1, we'll do everything in one go. BM equals lambda of BG. Now we need to develop a route from B to G. So first we need BG. So B to G, we can go from BF, FE, EG. So just write down BM lambda of BF plus FE plus EG. So BF is same as C, so that equals to lambda of C plus FE, same as A, and EG will be opposite to B, so minus B. And of course, expand the bracket. So BM equals lambda C plus lambda A minus lambda B. Next, we're going to do some work on equation 2 before we can merge it together. So that will be step 3. Step 2, we'll do something with equation 2. So from 2, OM equal mu of OE. Maybe you can pause the video, have a go. Okay, try to find an equation of OM will replace OE with all the A, B, and C's. So OE, we could go the different ways we do. I think the sort of the easiest for me will be O to A to G, and G to E. So OM will equal mu of O to A plus A to G plus G to E. It doesn't matter because it's a 3D, it's a cube. So there are different ways you can go from O to E. So OA is A, C, and B. Or A plus C plus B. A plus C plus B. So therefore, OM equals mu A plus mu C plus mu B. We've found our two lovely equations. Now it's time to put them in the blender and just put it together. So BM and OM. Okay. So I need to go from BM that involves OM. So from the cube, you can see I need to go from B to M with the help of O to M. So that will be B to O plus O to M. So I have to rewrite them. I have to write BM, B to O, O to M. So step 3, rewrite BM. So BM equals B to O plus O to M. So we know BM is lambda C plus lambda A minus lambda B, which equals to BO, which is minus B plus OM, mu A plus mu C plus mu B. So there are 3 variables in here. What should we do? Well, one by one, compare coefficient of A, B, and C. So this is that about merging, and then we're going to compare coefficients. So we compare A, you will see lambda equals to mu. If we compare B, a bit more interesting, negative lambda equals minus 1 plus mu. But if we compare C, we get lambda equals mu again. Well, I guess that's not much we can do in A and C. We can just put it in B. So minus mu equals minus 1 plus mu. 1 equals to mu, mu equals a half. Subsequently, lambda equals a half. Proven. So that's important that I have to stress out why we're doing the 2D version before we do 3D, because you can see it actually it's the same working. Okay. If it does come on an exam, count yourself lucky that I'm pretty sure they will not. I would say at least half the student won't be able to attempt it. And so, but these are easy marks if you know what to do. Okay. Right, that's the end of 12.3.